Welcome back to another section of the Ultimate Django course. In this section, you will learn how to query and manipulate data using Django ORM or Object Relational Mapper. We'll start off this section by a quick overview of Django ORM and the problem it solves. Then we'll spend the rest of the section on various ways to query and manipulate data. We'll cover filtering, sorting, grouping data, and much more. So by the end of this section, you'll be able to confidently pull out data or store it in a relational database. So let's jump in and get started. Let's start off this section by a quick overview of object relational mappers and the problem they try to solve. So you know that in relational databases, data is stored as rows in tables. So when pulling out data from a relational database, we need to map these rows into objects. In the past, we used to do this by hand, and this was pretty repetitive and time-consuming. So we would have to write a SQL query, send it to the database, read the result, and map it to a bunch of objects. So for each record, we will have to create a new object and set its attributes. This is where an object relational mapper comes into the picture. An object relational mapper, as the name implies, maps objects to relational records, and that frees us from writing a lot of repetitive code. So using an object relational mapper, we don't have to write SQL code to query or manipulate data. We can code in an object-oriented programming language like Python. The ORM will then translate our Python code into SQL code at runtime. So does it mean we never need to write SQL? No. When dealing with complex problems, ORMs can't produce efficient SQL queries. So that's when we need to jump in and write optimized SQL queries by hand. But overall, ORMs help us reduce complexity in our code, make it more understandable, and get more done in less time. A good example of that is Django migrations. Using these migrations, we generated our database tables almost instantly. We didn't have to write any SQL code or use a tool like DataGrip to create our tables, add relationships, indexes, and so on. Django migrations took care of all of that for us. So migrations are part of Django ORM. Also, all the model classes we have created so far inherit from the model class in Django. This model class is also part of Django ORM. So as you will see in this section, all our model classes inherit the functionality to query or manipulate data from the base model class. Now, once in a while, you see someone like our popular John Smith who hates ORMs and prefers to write every bit of code by hand because he believes ORMs are slow. What John is missing here is that he doesn't understand that the more code he writes, the more bugs he or someone else has to fix in the future. There is an old saying that says, the best code is no code. Writing and maintaining all that extra code costs time and money. Someone is paying for it, your employer or your client. If you were that person, you wouldn't want someone else wasting your money writing code that was unnecessary, right? Throughout my career, I've seen so many projects over-engineered by people like John that never made it into production. In my opinion, a good software engineer is one who delivers working software in time. Building the best, most optimized solution that will never make it to production is not something to be proud of. So use the right tool for the job. As I said, ORMs don't perform well when dealing with complex queries. But that doesn't mean we should never use ORMs. We can use them in a lot of cases, perhaps for the most part. Remember the old saying, premature optimization is the root of all evils. So don't optimize your code unless you have proof that it's slow. So that's it for the Django ORM. Let's move on to the next lesson. All right, before we get started, let's make sure that we're on the same page. I want to make sure that we're both using the exact same code and database. So what you see on your machine will be exactly the same as what I'm going to show you in the videos. So please follow everything I'm going to show you in this lesson. So at the beginning of the course, in the first section, I gave you a zip file that contains all the resources for this course. So here we have a folder called code that contains the code for each section. Now we're going to go to the fifth section and open the starter code. So here we have the storefront project. Let's drag and drop it into VS Code. Okay, we get a message saying no Python interpreter is selected. Don't worry about this. So let's close this. Now let's go to the settings module. And here in the section for our database settings, change the password of MySQL. Otherwise, you're going to get a connection error. So use the password for the root user. Next, we open a terminal window. And here we're going to run pipenv install. So this is going to create a new virtual environment and install all of our dependencies there. Okay, great. Now let's open up Data Grip or any tool you use for managing your database. Here we have the storefront database. I'm going to delete this database and recreate it from scratch. So delete. Good. Now you're going to right click on localhost and open a new query console. And here we're going to type create database storefront. Make sure to spell it properly because this is the name that we use in our project. Okay. So now we have a new database. Let's verify it. Great. So this database is currently empty. The next step is to run all of our migrations to create our tables. So back to our project. Here in the terminal, we run python manage.py migrate. Now we get an error saying invalid syntax because in this window, our virtual environment is not activated. So back to our project, let's activate our virtual environment. Good. Now we're going to run python manage.py migrate. Okay, all of our migrations are applied. So back to Data Grip, let's refresh. All of our tables are created, beautiful, but these tables are currently empty. So the next step is to populate them with data. But before doing so, I want to close all the sessions I have open in Data Grip. So down the bottom over here, we have the Services tab. I'm going to right click on localhost and close all sessions. Now I'm going to right click on Storefront and open a new query console. Now back in the resources folder, we have this data folder, and here we have a seed file that will populate 5 of our tables: collection, product, customer, order, and order item. So let's drag and drop this into this window. Good. Now on the top, we have to select the schema. So I'm going to select Storefront. Good. Now make sure that all these statements are selected. So currently all of them are selected. If not, just press Command and A on Mac or Control and A on Windows. And finally, we're going to execute them all in one go. Good. So now 5 of our tables are populated with data. Let's look at the customer table. All right. So here we have 1,000 customers. Beautiful. And now the final step is to start our server. So python manage.py run server. Great. So now that we're on the same page, let's move on to the next lesson. All right, the first thing you need to understand about Django ORM is the concept of managers and query sets. So let's press Command and T on Mac or Control and T on Windows and jump to our say hello function. So we're going to go back to our playground and write all the code here. Now for this section, we don't really need the calculate function, so I'm going to delete it. And I'm going to delete this line as well. Now on the top, from store.models, we're going to import the product class. Now, every model in Django has an attribute called objects, and this returns a manager object. A manager is an interface to the database. It's like a remote control with a bunch of buttons that we can use to talk to our database. So here we have a bunch of methods for querying or updating data. For example, we have all for pulling out all the objects in the products table. We also have get for getting a single object. We have filter for filtering data and so on. Now, most of these methods, like the all method, return a query set. So when we call this method, we don't get a list of products. We get a query set object. A query set is an object that encapsulates a query. So at some point, Django is going to evaluate this query set, and this is when Django will generate the right SQL statement to send to our database. But when will this happen? Well, under a few scenarios. One scenario is when we iterate over a query set. So if you write code like for product in query set, at this moment, Django will evaluate this query set and get the result from the database. So for this demo, let's just print the product on the terminal. Now save the changes. Back in the browser, here on the hello page, let's refresh. Okay, now let's open Django debug toolbar. So look at the SQL tab. Over here, you can see the actual SQL statements that Django sent to our database. So here we have 3 queries. The first 2 are just used by Django to do its job. The third query is our select statement to get all the products from the products table. So let's expand this. This is the exact query that Django has sent to our database. So select ID, title, slug, and other fields from product table. Now over here, we can click on the select button to see the actual result that is returned from the database. So this is very useful when debugging applications. Now back to our code. So one scenario where a query set is evaluated is when we iterate over it. Another scenario is when we convert it to a list. So if we call the list function and give it this query set will be evaluated. Another scenario is when we access an individual element, like the first element, or when we slice this. So if we use the slice operator and pick the first 5 elements, then the query set will be evaluated. So because of this, we say query sets are lazy, which means they're evaluated at a later point. Now you might be wondering why query sets are lazy. Why doesn't Django simply call the database the moment we call the all method? Well, the reason for this is that we can use query set methods to build complex queries. So over here, we can call query set.filter to filter the result, and this will return a new query set. So once again, the query is not going to get evaluated at this point. So we get a new query set, and then right away we can call the filter method to apply a second filter. Then similarly, we can call the order by method to sort the result. So by chaining all these methods, we'll build a complex query, and at some point when we iterate over that query or convert it to a list, that query will be evaluated. Now imagine if query sets were not lazy. The moment we call the all method, the query would be evaluated, and this would result in thousands or even millions of objects returned from the database. But what if you were only interested in a subset of these products? Then calling the filter method would filter the objects in memory. So we would get thousands or millions of objects, we'll store them in memory and throw most of them out. So to recap, every model has an attribute called objects, which returns a manager, which is an interface to the database. Now, the manager has a bunch of methods for querying and updating data. Most of these methods, like the all method, return a query set. Now, in contrast, we have some other methods that return result immediately. For example, we have the count method, which returns the number of records in the product table. Now, why don't we get a query set here? Well, because this method returns a number, so it doesn't really make sense to do something extra with that number. We're not going to apply a filter to it. We're not going to sort the result or build a complex query around it. So this was the basics of managers and query sets. As we go through the section, you will learn more about these query sets. Next, we're going to talk about retrieving objects in detail. All right, in this lesson, we're going to talk about a few different methods for retrieving objects. The first method is the all method that we briefly talked about in the previous lesson. This method returns a query set, and when this query set gets evaluated, we get all the objects in a given table, like the product table. Now, sometimes we want to get a single object, like the product with the ID 1. To do that, we use the get method, and here we pass a lookup parameter like ID equals 1. Now, we could also use pk. That's a special argument. So when we use pk, Django will automatically translate this to the name of the primary key field. So our primary key field might be ID, it might be code, whatever. We don't have to remember. This is the benefit of using the pk argument, okay? Now, unlike the all method, the get method returns an actual object, not a query set. The reason for this is because once we get an object, it doesn't really make sense to do anything extra with it. We're not going to sort the result. We're not going to apply additional filters and so on. So here we get a product, and that means we should rename this variable to product. So always pay great attention to the name of your variables and functions. I cannot emphasize this enough because this is one of the main issues I see in a lot of people's code. They have a function like get airplane. So you see that function and you think you're going to get an airplane. But when debugging the application, you realize that this function actually returns an orange, and that orange ends up getting stored in an object called book. Don't do this. So always pay great attention to the name of your variables, okay? So let's save this and see what we get. Back to the browser, refresh. Let's look at the SQL tab. So here's our select statement. So we're selecting all these columns from the product table, and here we have a where clause to select the product with the ID 1. Now Django also adds a limit clause, a limit of 21. I'm not entirely sure why they use 21 here. To me, it looks like a magic number, but this is something you can find in Django source code. So for now, don't worry about it. This limit doesn't really make a difference for us. Now, one thing you need to know about the get method is that if it cannot find this object, it will throw an exception. So if we set pk to 0, look, we get an exception of type does not exist. So to handle this, we have to wrap our code inside a try-catch block. So back to the code. First, we're going to import the type of the exception on the top. So from django.core.exceptions, we're going to import object does not exist. Now note that I've put all my Django import statements next to each other, so my code is cleaner and more organized. Compare this with this. So we are importing something from Django, then something from another app, then we're going back to Django. Again, this is a little bit ugly. So I prefer to put all Django import statements next to each other. Now we need to wrap this line inside a try-catch block. Don't tell me that you don't know what a try-catch block is, because I covered it in detail in my Python course. So here we type try, then we type except, followed by the type of exception, which is object does not exist. Also, note that you don't have to type the full name of the class. So here I'm typing objdne, and with that we can easily look up this class. So we can use abbreviations, okay? Enter. Now in a real scenario, here we want to show an error to the user, but for now, don't worry about it. So I just want to pass, okay? Now back to the browser, refresh. This time we didn't get an exception. Great. Now, this try-catch block looks a little bit ugly. We don't want to repeat this pattern over and over in our code. So let me show you a better way. First, I'm going to delete the try-catch block. Good. Now, instead of the get method, we can use the filter method. Now, this method returns a query set. So right away, we can call the first method of the query set. Now, if the query set is empty, the first method returns none. So in this case, product is going to be none. We're not going to get an exception. Check this out. So save and refresh. Great. Now, sometimes we want to check the existence of an object. So over here, right after the filter method, instead of the first method, we can call another method called exists. So first we apply a filter, and then we check to see if there is an object in our query set with this criteria. So in this case, we're not going to get a product object. We get a Boolean value. So we should rename this variable to something like exists, okay? So these are various ways to retrieve objects. Now in the next lesson, we're going to talk about filtering in detail. All right, let's talk about filtering data. So let's say we want to find all the products that are $20. So here we pass a keyword argument and say unit price equals 20. Pretty straightforward. Now, what if you want to find all the products that are more expensive than $20? We cannot use our logical operators here. Look, we have an error because this expression, this piece of code is a Boolean expression and returns a Boolean value, which can be true or false. But when calling the filter method, we need to pass a keyword argument. So we need to pass a keyword followed by a value, right? So to solve this problem, after the field name, we type 2 underscores followed by a lookup type. So in Django, we have GT, which is short for greater than. We also have greater than or equal to. We have less than or equal to. So for this demo, I'm going to change this to GT equals 20. Now we're passing a keyword argument to this method, but the name of our keyword is kind of special, right? Save the changes. Now to find all these lookup types, you can search for query set API, and on this page, look over here. Where is it? It's right here, field lookups. So we have various lookup types for numbers, strings, and dates. In this lesson, we're going to cover a lot of them, and I'm going to leave the rest to you. So back to our code. Another useful lookup type is range. And with this, we can find the products whose price is in a given range. So over here, we cannot pass a single value. We need to pass two values, a minimum and a maximum. So we need to pass a tuple with two values, let's say 20 and 30. Now, out of curiosity, let's render these products in our template and see what we get. So here's the context, the object that we're passing to our template. In this object, in this dictionary, I want to add another key value pair called result. We could also call it product, that's better, and set it to query set. So we're passing the query set here. Now it would be better to convert this to a list, so the name of the key reflects the type of the value. Once again, we don't want to get an airplane and store it in a book, right? So save the changes. Now let's go to hello.html. And after our if block, we're going to render an unordered list, which represents a list of bullet points. So tab. Inside the unordered list, we're going to add a for loop. So we add a pair of braces with ampersand. And here we say for product in product. We don't need a colon here, just the expression, okay? Now, in our for loop, we're going to type a list item for rendering a bullet point. And over here, we add two braces to render product.title. Finally, we need to close our for loop. So once again, braces with ampersand. And here we type and for. Now back to the browser. Here are the products whose price is between $20 to $30. Great. Now we can also filter across relationships. So let's remove this argument. Let's say we want to find all the products in collection number 1. So here we type collection, followed by 2 underscores. So we navigate the relationship. And over here, we can type the name of any of the attributes or fields of the collection class. So we can say ID equals 1. We can also use our lookup types. So we can add 2 underscores followed by a lookup type, like greater than or range. And then we can set this to a tuple of, let's say, 3 values. So with this, we get all the products in any of these collections, okay? So these were the lookup types for dealing with numbers. Now let's look at an example involving a string. So I'm going to remove this argument. So let's say we want to find the products that contain coffee in their title. So over here, we can type 2 underscores and use the contains lookup type. We set this to coffee. And with this, we don't get anything because this lookup type is case sensitive. So to perform a case insensitive search, we have to use iContains. Now take a look. So here are all the products that have coffee in their title. Now we also have starts with, ends with, as well as their case insensitive variation, okay? Now, for dates, we have a bunch of lookup types. So let's say we want to find all the products that were updated in 2021. So last update, double underscore, here we can use year and set it to 2021. Now take a look. So this is what we get. So we can extract individual components in a date like year, month, minute, second, and so on. We can also compare this with a date value, not something we use that often. And the last lookup type I'm going to cover here is checking for null. So to get all the products without a description, we can say description, double underscore is null equals true. We don't get anything because all of our products have a description, okay? Now it's your turn. I've attached a PDF below this video. In that PDF, you're going to find a bunch of exercises and their solutions. So make sure to do these exercises before moving on to the next lesson, where we talk about complex filtering. All right, let's see how we can apply multiple filters. So let's say we want to find all the products with inventory less than 10 and unit price less than 20. There are a couple of different ways to implement this query. One way is to pass multiple keyword arguments here. So we can say inventory less than 10. And here we pass a second keyword argument and say unit price less than 20. So let's go back to the browser, refresh. Here are the products we get. Let's look at our SQL query. So here's our select statement. as you can see, in the where clause, we have two conditions combined using the AND operator. Okay? Now, there is another way to write the same query. Instead of passing multiple keyword arguments, we can chain the call to filter method. So I'm going to remove the second keyword argument. So here we have the filter method. The filter method returns a query set. Now we can get that query set and apply a second filter on it. So here we can say unit price less than 20. Now here we get a new query set, which we store in this object. And the moment we call the list function, this query set will get evaluated. So if we go back to the browser and refresh, we get the same result as before. So let's take a look at our query. So exactly like before, where we have two conditions combined using the AND operator. Now, how can we combine these conditions using the OR operator? Well, to do that, we have to use QObjects. Back to our code. First, we need to import the Q class from Django. So from Django.db.models, import Q. So Q is short for query. And using this class, we can represent a query expression or a piece of code that produces a value. Okay? So using this Q class, we can encapsulate a keyword argument. So let me remove all this code and start from scratch. So we want to combine these conditions using the OR operator. So here we say filter. Now, instead of passing a keyword argument here, we're going to pass a Q object. So we create a Q object, and right here we pass a keyword argument. So we say inventory less than 10. So each Q object encapsulates a keyword argument or a query expression. Now we can combine this Q object with another Q object using the bitwise operators. So if we use the bitwise OR operator, this will translate to a logical OR in a SQL query. So here we pass a second Q object and add the second condition, unit underline price less than 20. Now, let's save the changes. So here's what we have implemented. Back to the browser, refresh. Let's look at our query. There you go. So two conditions combined using the OR operator. Beautiful. Now back to our code. Here we can also use the AND operator, but this syntax is a little bit too verbose. If you want to combine multiple conditions using the AND operator, we don't really need Q objects. We can simply pass multiple keyword arguments to the filter method, just like before. Now here we can also negate a Q object. So this will translate to the NOT operator in SQL. So when we execute this, we'll get all the products whose inventory is less than 10 and their unit price is not less than 20. Okay? So this is how we can build complex lookups using Q objects. Next, we're going to talk about referencing fields using F objects. Sometimes when filtering data, we need to reference a particular field. For example, let's say we want to find all the products where their inventory equals their unit price. Now, I know this doesn't really make sense in terms of a business rule, but let's just imagine that we want to compare two fields. So here in the filter method, if we say inventory equals unit price, we get an error because unit price is not a valid value for this keyword argument. Where is unit price defined? We don't know, right? Now, if we convert this to a string, that's not going to work either because the inventory field is a number and we cannot compare a number with a string. So to solve this problem, we need to use an F object. So first on the top, from the same models module, we're going to import the F class. Now using this class, we can reference a particular field. That's why it's called F. So over here, we're going to create an F object, and in the constructor, we're going to pass the name of a field. Okay, so let's run this query and see what we get. Refresh. Obviously, we don't have any products that satisfy this criteria, but let's look at our SQL query. So over here, look at the where clause. We're finding products whose inventory equals their unit price. Now, using F objects, we can also reference a field in a related table. For example, here we can say collection, _ID, and with this, we'll compare the inventory of a product with the ID of its collection. Okay? So this is how we can reference fields using F objects. Pretty simple. Next, we're going to talk about sorting data. All right, let's talk about sorting data. So here we have this order by method that I briefly mentioned before. Using this method, we can sort the result by one or more fields. For example, here we can get all the products and sort them by their title in ascending order. Take a look. So save and refresh. There you go. So all the products are now sorted in alphabetical order. Beautiful. Now let's look at the SQL tab. So here's our query. Now with this implementation, we have an order by clause for sorting the products by their title in ascending order. If you want to change the sort direction, we simply add a negative sign here. Now we can also sort by multiple fields. For example, we can sort by unit price in ascending order and then by title in descending order. So with this implementation, we're going to sort our products from the cheapest to most expensive ones. And if we have multiple products with the exact same price, within that group, our products are going to be sorted by their title in descending order. Okay? Now, the order by method returns a query set object, and one of the methods of query sets is reverse. So if we call the reverse method here, this will reverse the direction of the sort. So with this implementation, we're going to sort the products by unit price in descending order and then by title in ascending order. Now we can also call the order by method after filtering data because the filter method returns a query set object and order by is one of the methods of query set objects. So here on query set API reference, over here, you can see all the methods of query set objects. So we have filter, exclude, order by, and so on. So as an example, we can filter all our products to get products in collection 1 and then sort them by their unit price. Pretty straightforward. Now, sometimes we want to sort the result and pick only the first object. So let's remove the filter method here. We're simply sorting our products by their unit price and then we're going to pick the first product. So with this implementation, we're not going to get a query set because we're accessing an individual element. So up to this point, when we call the order by method, we get a query set object, but the moment we access an individual element in this query set, the query set gets evaluated and then we get an actual object. So we should rename this variable to product. And of course, we need to make a change here because we're not going to convert this to a list. So instead of products, we're going to pass product to our context. And of course, we need to change our template to accommodate this, but let's not worry about that in this video. What I want to show you instead is a convenience method called earliest. So another way to rewrite the same query is like this. Instead of order by, we can call the earliest method to sort the result by unit price and get the first object. So with the second implementation, we're not going to access an individual element because the earliest method returns an object. In contrast, order by returns a query set. Now, similarly, we have another method called latest, which sorts the products by unit price in descending order, and then it will return the first object. Okay? So this is all about sorting data. Next, we're going to talk about limiting results. So our product table has 1,000 products. Now, quite often, we don't want to show all these products to the user in one list. We want to show pages of products. So let's say our page size is 5 and we want to show the products on the first page. To do that, we use Python's array slicing syntax. So if we type :5 here, this is going to return the first 5 objects in this array. So more accurately, we're going to get objects at these indexes, 0, 1, 2, 3, and 4. So excluding 5, okay? Now, let's go back to the browser and refresh. So here are the first 5 objects or first 5 products. Now let's look at the SQL tab. So now in our query, we have the limit clause for getting the first 5 products. Now to get the products on the second page, we can start from 5 and finish before 10. So this is going to return the product objects at these indexes, 5, 6, 7, 8, and 9. Now, refresh. With this implementation, our query is going to have an additional clause. So we have limit 5 followed by offset 5 for skipping 5 records. So you have seen that when we query objects, by default, all of their fields are read from the database. But what if you're only interested in a subset of these fields? For example, look at our product table. Our product table has a bunch of fields or columns. Some of these columns, like the description column, contain a lot of text. What if we don't care about the values in this column? What if we only want to return the ID and the title of each product to the user? This is where we use the values method. So we call the values method and specify the fields we want to query. Let's say ID and title. Now, refresh. We get the same result as before, but look at our query. With this implementation, we're only reading the ID and the title of each product, okay? Now, we can also read related fields. For example, we can go to the collection and read the title field. So using the double underscore notation, we can access the related fields. Now, let me show you something interesting. So back to the browser, refresh. Let's look at our query one more time. With this implementation, now we have an inner join between the product and the collection tables because we are reading a related field. So this is how we can use the values method. Now, one thing you need to know about this method is that with this method, instead of getting a bunch of product instances, we get a bunch of dictionary objects. Let me show you what I mean. So let's go to our template. Instead of rendering product.title, let's just render the product object itself. So save and refresh. See what's happening? So each object in the result is a dictionary. It's not a product instance. So in this dictionary, we have 3 key value pairs. We have ID, title, and collection double underscore title. Now we have another method called values list. And with this method, we get a bunch of tuples instead of dictionaries. So take a look, refresh. Now each object is a tuple of 3 values. So here we have the ID followed by the title of the product and the title of the collection. Now here's your exercise. I want you to write a query to select products that have been ordered and sort them by their title. Now let me give you a hint before you get started. So in our database, we have this product table that contains all the products in our system, but not all products have been ordered. So to find the products that have been ordered, you need to go to the order item table. Here we have a column called product ID. You need to select all these values, all these product IDs, and use them as an argument when filtering products. So spend a couple minutes on this, then come back see my solution. All right, the solution. As I said, we should start with the order item table. So first we go on the top and import the order item class. Now we go to order item, the objects. Now here we need to select all the product IDs from this table. So this is where we use the values or values list method. It doesn't really matter. So I'm going to go with values because it's shorter. So we go to values. Next, we go to the product field and select the ID field. Now we can also use a single underscore because Django will automatically create this field for us at runtime. So even though we didn't declare a field called product ID on the order item class, look, we only have product, right? But Django will automatically create a field called product underline ID at runtime. And essentially this is our foreign key field. Okay. So back to our query, we select product IDs and store the result in query set. Let's test our implementation up to this point. So here in the browser, this is what we get, a bunch of dictionaries. And as you can see, we have a lot of duplicates. Now, before I show you how to resolve duplicates, let's look at our query. So we have a simple query for selecting product ID from the order item table. Beautiful. Now, to get rid of duplicates, here we can use the distinct method. So values returns a query set, and distinct is another method of query set objects. With this, let's go back to the browser and refresh. We no longer have duplicates. Beautiful. Now the last step. We want to go to the product table and select all products with these IDs. Very simple. So we're going to say product.objects.filter ID _in. So here I'm using the in lookup type to find all products whose ID is in a given list. And we're going to set this to this expression over here, where we select product IDs from order item table. So cut, move it here, and we're going to set the query set right here. So this is the end result. Let's see what we get in the browser. So refresh. We get a bunch of product objects. So product with ID 1, 4, 5, and so on. Now let's go to our template and render the title of each product. So instead of rendering the product, we're going to render product.title. And there you go. So here's the list of products. Now the last thing we need to do is sort the list. So after we filter our products, we're going to call the order by method to sort the products by their title. Now, take a look. Here's the final result. These are the products that have been ordered. So in the last lesson, you learned how we can optimize our queries by specifying the fields we want to query. Now, we have another technique called deferring fields. So we have a method called only, and with this method, we can specify the fields we want to read from the database. Let's say ID and title. Now you might be wondering how this method is different from the values method. Well, with the only method, we'll get instances of the product class, whereas with the values method, we'll get dictionary objects, okay? Now let's save the changes. Back in the browser, refresh. So we get the same result as before. Let's look at our SQL tab. So here's our query. Pretty simple. We're selecting the ID and title from the product table. Great. So this is how the only method works. Now you got to be careful with this method. If you don't know what you're doing, you will end up with a lot of queries sent to the database under the hood. Let me show you what I mean. So let's go to our template, and after the title of each product, render its price. So we add a $sign here, followed by 2 braces, and here we render product.unit_price. Let's save, back in the browser, refresh. Look what's happening. Our application is freezing. So it's going to take several seconds until we see the result. All right, here's the result. Now let's look at our SQL tab. How many queries do we have here? 1,002. Let's see what's going on here. So here's our main query where we read the ID and title from the product table. Now, after the main query, for each product, we have a separate query to read its price. So look at this query. Here we are reading the ID and unit price from the product table where ID equals 1. We have a similar query for every other product in this list. So because we have 1,000 products in this list, we have 1,000 extra queries for reading the price of all these products. This is what I was talking about. So you have to be careful when using the only method. If you don't know what you're doing, you'll end up with a lot of extra unnecessary queries. Now we don't have this problem with the values method, because with the values method, we get dictionary objects, and these dictionary objects don't have this behavior. So if you access a field that doesn't exist in a dictionary, that dictionary is not going to issue a query to the database, okay? Now we have another method, which is the opposite of the only method, and that is called defer. With this method, we can defer the loading of certain fields to later. So let's say our product table has a bunch of columns. We're interested in all of them except the description field. So we can defer this to later. But once again, you have to be careful. So if somewhere else you have, let's say, a for loop, and in that loop, you're iterating over the products and rendering the description of each product, once again, you're going to end up with all those extra queries. Sometimes we need to preload a bunch of objects together. For example, here we're loading all the products. Now, let's go to our template and render the collection of each product next to its title. So here we add a hyphen, followed by 2 braces to render product.collection.title. Now save, back in the browser, refresh. Look, we have the same problem as before. Our application is hanging because Django is sending 1,000 extra queries to the database to read the collection of all these products. Because when we ask for products, Django is only going to query the product table. It's not going to query the related tables unless we specifically instruct it to do so. So here we want to preload the products with their collection. To do that, before we call the all method, we call select related. And here we specify the field we want to preload. So that field is collection. Then we call the all method. Now, back to the browser, refresh. Our products loaded instantly. Now, let's look at our SQL tab. So here's our query. See what's going on here? We're selecting all these fields from the product table, followed by these 3 fields from the collection table. And here we have a join between product and collection. So when we use the select related method, Django creates a join between our tables. Now, we can also span relationships. So let's say collection has another field that we want to preload as part of this query. So we add 2 underscores here and then type the name of that other field. Okay. So this is select related. Now we have another method called prefetch related. So we use select related when the other end of the relationship has one instance, like in this case, a product has one collection, right? But we use prefetch related when the other end of the relationship has many objects. What is an example of that? The promotions of a product. So let's go to the product class real quick. Look, each product has one collection, but it can have many promotions. So to preload the promotions, we use the prefetch method. So back to our playground, I'm going to replace this with prefetch related. And the field we want to preload is promotions. Now, before we go back to the browser, I'm going to go back to the template and remove the collection of these products. Otherwise, we're going to end up with all those extra queries. So save. Now refresh. All right, let's look at our SQL tab. So now we have 2 queries. Here's the first query to read all these columns from the product table. Now, after that, we have another query to read the promotions of these products. So we are reading 3 columns from the promotion table, and we have a join between promotion and product. So essentially, we have 2 result sets. The first set includes the products. The second set includes promotions. Django reads these sets and then populates our objects in memory. Now, we can also combine these 2 methods. So let's say we want to load all the products with their promotions and collection. So after the call to prefetch related, we can call select related to load the collection of each product. So both these methods return a query set, and that's why we can chain all these methods to build a complex query. Okay. Now the order of these methods doesn't really matter. So we can put select related first or last. It doesn't really make a difference. So now let's save the changes and add the collection back in our template. So product.collection.title. Now let's test the result. Great. So we see the collection of all these products. Now in our SQL tab, we have 2 queries. The first query is to read all the products and their collection. So here we have a join between product and collection. And the second query is to read the promotions of all these products. All right, here's your exercise. I want you to write a query to get the last 5 orders with their customer and items, including the product referenced in each order item. So pause the video, spend a couple minutes on this, then come back, see my solution. All right, here's the solution. We want to get a list of orders, so we should start with the order class. Then we go to objects. Now we want to preload these orders with their customer. So this is where we call select related to preload the customer field. Now we don't want to show all the orders. We want to show the last 5 orders. So first we need to sort them by place that in descending order. So the latest orders come first. And then we use array slicing syntax to pick the top 5 orders, okay? Now let's test our implementation up to this point. So we store the result in query set, and then to keep our code clean, we should change the name of this key from products to orders. Next, we go to our template and rename products to orders and product to order. Now here we can render the ID of each product followed by, let's say, the first name of the customer. So 2 pairs of braces to render order.customer.firstName. Save. Now here we can see the last 5 orders and the customer. Beautiful. Let's look at our SQL tab to make sure we don't have any extra queries. So we have a single query to read the orders and their customer. So we're selecting all these columns from the order table, followed by all these columns from the customer table. And here we have a join between order and customer tables. Great. So let's move on to the next step. Now we should preload the items of these orders. So here we call prefetch related because each order can have many items. Now, what is the name of the field we're going to query? Well, let's have a quick look at our order class. So each order has 3 fields: placed at, payment status, and customer. We don't have a field called items. But look at the order item class. Here we have order, which is a foreign key to order. So Django is going to create the reverse relationship for us. Now, what is the name of that relationship? That is order item underline set. This is the convention that Django uses to create the reverse relationship. If you don't like this name, you can set it using the related name argument. So over here, we can set related name to items. So with this implementation, the order class is going to have a field called items. Now, I don't want to set this because we're going to end up with inconsistency in our code. And I don't want to change the name for every relationship. So for the purpose of this exercise, let's go with Django's convention. So back to our playground, we want to prefetch order item underline set. So the name of the target class in lowercase followed by an underscore and set. Okay. Let's see what we get up to this point. So refresh. Our page loaded instantly. Let's look at the SQL tab. We have one extra query to load these order items. So we're loading order items for orders in this list. So everything is fine so far. Now the last step is to load the product referenced in each order item. So over here, where we are prefetching the order item, we can span the relationship by adding 2 underscores, and then we type the name of the target field, which is product. Save. Now refresh. Let's look at our query one more time. Now we have one extra query to read the products referenced in these order items. So we are reading all the columns from the product table where the ID of the product is in this list. And this list is the list of order items we have queried so far. So this is how I want you to write code. Write a little bit of code, test your code, make sure everything works before doing a big step. With this technique, you can prevent a lot of crazy issues down the road. Sometimes we want to compute summaries like max or average price of our products. This is where we use the aggregate method. So we call product.objects.aggregate. And here we pass an aggregate object. So first on the top, we import an aggregate class. So from Django.db.models.aggregate, we import one of these classes. So we have count, we have max, min, average, and sum. So let's say we want to count our products. Here we create a count object and specify the field we want to use for counting. If we use ID, we can count the total number of products because every product has an ID. But if we use a different column, let's say description, and assume that description can be null, this will count the number of products that have a description. Okay? So the proper way to count the total number of records is to use the ID or the primary key field. Now, the aggregate method doesn't return a query set because once we calculate a summary value, it doesn't really make sense to do anything extra with it. We're not going to add filters or sort data and so on. So here we get a dictionary. Let's call that result and add that to our context object over here. So I'm going to add a new key called result and set it to result. Okay. Now we go to our template and I cleaned up the code from the previous lesson. So we don't have a for loop for rendering the list of orders. So right after our hello world message, we can render the result object. Now let's see what we get. Refresh. So we get a dictionary with one key value pair. Look at the name of the key. It's ID _, count, because we use the ID column for counting objects. And as you can see, we have 1,000 products in this table. Now we can easily change the name of this key. So back to our code. Over here, we can pass a keyword argument. We can say count equals this. Now take a look. So the key is renamed. Pretty simple. Now we can also calculate multiple summaries. So in addition to the total number of products, we can also calculate the minimum price of our products. So we can pass another keyword argument, say min price, and set it to min of unit underline price. So here's what we have. We have two keyword arguments, count and min price. Let's see what we get in the browser. So refresh. There you go. Min price is a decimal object with this value. Now, one last thing before we finish this lesson. Since aggregate is one of the methods of query sets, we can apply it wherever we have a query set. So we can filter our products and pull out the products in a given collection. Let's say collection number 1, and then calculate these summaries over that data set. All right, so that's all about aggregating objects. Now I've attached a PDF below this video where you can find a bunch of exercises and their solutions. Make sure to do these exercises before moving on to the next lesson. Sometimes we want to add additional attributes to our objects while querying them. This is where we use the annotate method. So we go to customer.objects and call the annotate method. Now let's say while querying customers, we want to give each customer a new field called isNew, and we want to set it to true. So let's get the result and store it in a query set. Now in our context object, I'm going to add a new key value pair called result and set it to list of query set. Now in our template, we are not doing anything in this lesson. So let's just focus on the code here. Now here in the browser, refresh, we get this error saying query set.annotate received none expression. What this error is telling us is that we cannot pass a Boolean value over here. We need to pass an expression object. So in Django, we have this expression class, which is the base class for all types of expressions. Derivatives of this class are value for representing simple values like a number, a Boolean, a string. We have f, which you have seen before. Using the f class, we can reference a field in the same or another table, right? So an f object is essentially an expression object. We also have func for calling database functions. So all these database engines have a bunch of functions for manipulating data. To call those functions, we use a func object. I'm going to show you that in a second. We also have aggregate, which is the base class for all aggregate classes. So those aggregate classes you learn about like count, sum, max, and min, all these classes derive from the aggregate class. Okay, so let's go through a few examples. So back to our code, we cannot pass a Boolean value here. We need to pass an expression object. The simplest expression object is a value object. So on the top, from Django.db.models, we're going to import the value class. And now we're going to wrap this value inside a value object. So we pass value of true. Okay, now save, take a look. No more errors. Let's look at our query. So I'm going to execute this query. So in the list of customers, now we have a new column called isNew, which is populated by 1, which is the numeric equivalent of a Boolean true. So when Django reads this data, it's going to give each customer a new field called isNew, and it's going to set it to true. Let's look at another example. This time, we want to give our customers a new field called new ID. And for this demo, we want to set this to the same value as the ID field. So we need to reference another field in this model. To do that, first we need to import the F class from Django.db.models. And then over here, we can reference the ID field. Now, let's run our query one more time. So take a look. Now we have a new column called new ID, which is populated with the same value as the primary key. Now we can also perform computations here. So for example, we can add 1 to the ID to generate the new ID. Now take a look. So now the new ID is the original ID plus 1. All right, now let's see how we can call a database function. So from the same module, we're going to import the func class. Now we're going to give our customers a new field called full name. And this is where we're going to call the concat function of a database engine. So pretty much all database engines have this function for concatenating strings. So here we're going to create a func object and give it a bunch of arguments. So we want to specify 2 fields here, first name and last name. How can we reference fields? Using f objects. So f of first name and f of last name. Next, we need to give this a keyword argument that specifies the target function. So we set function to concat. Okay. Now, if we run our query, first name and last name are going to be concatenated, but we also need to add a space in between. So we cannot pass a white space here. We need to pass an expression object. So we need to wrap this inside a value object. Okay. Now let's run our query and see what we get. So refresh. And here's our query. Take a look. So in our query, we are selecting all these columns from the product table, but we also have a new computed column using the concat function of MySQL. So we're concatenating first name with a space and last name. And here in this table, we have the full name of each customer. Great. Now there is also a shorthand to achieve the same result. So back to our code. First, we're going to import the concat class from Django. So from Django.db.models.functions, we're going to import the concat class. And then we're going to use that class instead of a func class. So let me duplicate this query so you can compare them side by side. In the second implementation, we are not going to create a func object. We're going to create a concat object. Now here we need to specify our fields. So first name and last name. Now note that over here, I'm not wrapping these fields inside an f object. So that is the benefit of using the concat class. But to add a white space, we need to wrap it inside a value object because otherwise Django thinks this is a column in our table. So let's wrap this inside a value object. Good. Now, unlike the first method, we don't have to specify the target function because that is reflected in the class itself. So the code is shorter and gives us the exact same result. Now, if you're curious about Django database functions, just Google Django database functions. On this page, you can see various functions in different categories. For example, we have a bunch of functions for working with dates. We have mathematical functions. We have functions for manipulating text and so on. These functions are common across all database engines, but different database engines have their own unique functions. So to call those functions, you have to go back and use a func object. Now let's say we want to see the number of orders each customer has placed. So we're going to annotate our customers with a new field called orders count. And here we're going to use the count class. Now look, VS Code offers to automatically import this class for us. So we just press enter and it's imported on the top. Now let me show you a shortcut. We can also import the count class from the models module. And with this, we can avoid an extra import statement. Now, what is the difference between these two classes? Nothing. The models module simply imports the count class from the aggregates module and then re-exports it. Okay, so let's delete this line. Good. So we create a count object. Now, what field should we use to count the number of orders? Well, let's go to our customer class. So our customer has these fields, but we don't have a field called orders. So let's look at the order class. Here we have customer, which is a foreign key, right? And you know that with this implementation, Django is going to create the reverse relationship for us. So here in the customer class, we're going to have a field called order underline set. So the singular name of the target class followed by underline set. And this is all in lowercase. Now, for some reason that is known to Django developers, we cannot use this name to count the number of orders for each customer. Let me show you what I mean. So back to our playground, if we type order underline set here, we get an exception. Look, cannot resolve keyword order set into field. Our choices are address, birth date, email, first name, ID, last name, membership, order, and phone. So the name of the field that we should use for counting is order. Why? Honestly, I don't know. So back to our code, let's change this to order and rerun our query. Great. Now let's look at our query. So now we're selecting all these fields from the customer table, and we're also counting the number of orders. Now look, we have a left join between customers and orders because not every customer has an order. Now, if you're not familiar with left joins, you really need to look at my SQL course. I cover this in detail there. And finally, we have a group by clause for grouping the number of orders for each customer. So if you run this query, we can see the number of orders for each customer. So let's quickly recap what you have learned so far. We talked about the expression class, which is the base class for all types of expressions. Derivatives of this class are value for representing simple values like a boolean, a number, a string. We have f for referencing fields, func for calling database functions, aggregate, which is the base class for all aggregate classes like count, sum, and so on. Now, in this lesson, we're going to talk about another derivative of the expression class called expression wrapper. We use this class when building complex expressions. So here's an example. Let's say we're going to annotate our products and give them a new field called discounted price. So here we're going to get the unit price and multiply it by, let's say, 0.8. Now, if we run this query, we're going to get an exception. So take a look. So we get this error saying expression contains mixed types because we have mixed a decimal field, which is our unit price field, with a float field, which is our 0.8 number. Now the error is saying that we must set the output field. So to solve this problem, first we need to import the expression wrapper class from the same module, from the models module. Now we should wrap this expression inside an expression wrapper object, and that's where we specify the type of the output field. So to keep our code clean, I would prefer not to wrap this expression right here. I would prefer to create an expression wrapper object over here. Then we move this right here. And as the second argument to the constructor of this class, we specify the output field. So we need to decide what is the type of the output field. For monetary values, we should always use a decimal field because float fields have a rounding issue and are not very accurate. So back to our code, we set the output field to a decimal field object. So make sure to create an object, we're not simply passing the name of the class, we're creating an object, okay? Now we can store the result in a separate object like discounted price, and then use that over here. Now let's run our query. Okay, no more error. So let's see what is sent to the database. There you go. We have a new computed column, which takes the unit price and multiplies it by 0.8. So this is how we can use expression wrapper objects. Now, once again, there is a PDF below this video where you can find a bunch of exercises and their solutions. So spend a few minutes on those and then come back, see the next lesson. All right, let's talk about querying generic relationships. So earlier in the course, we created the tags app with two models. We have tag and tagged item. Now, if you remember, we decided to use the content type framework to decouple this app from the store app. So this app knows absolutely nothing about the store app. It doesn't know we have a model called product. So with this decoupling, we can reuse this app in any kind of project. Tomorrow, we can use it to tag articles, blog posts, videos, and so on. But now let's see how we can find the tags for a given product. So let's go to our database and look at this table, Django content type. In this table, we can see all the models we have in our application. So in the admin app, we have a model called log entry. We didn't create this. This is built into the admin app that comes with every Django project. Similarly, in the auth app, we have three models, group, permission, and user. In the likes app, we have a model called liked item. And in the store app, we have all these models that we have defined so far. Okay? So this is the content type table. Now let's look at the tagged item table in the tags app. So here we have a few columns, object ID, content type ID, and tag ID. So to find the tags for a given product, first we have to find the content type ID of the product model. So in this table, currently in my database, we have the product model and the content type ID for this model is 11. So once we find this, then we can go to this table and write a query to filter all records where content type ID equals 11 and object ID equals the ID of the product whose tags we want to find out. That is the big picture. Now let's implement this in code. So back to our playground, first we have to import a few classes. From Django.contrib.contenttypes.models, we're going to import the content type model. This is the model that represents the content type table that you just saw. Then from store.models, we're going to import the product class. And finally, from the tags.models module, we're going to import the tagged item class. Now, first we need to find the content type ID for the product model. So here we say content type dot objects. So because content type is a model, it has the objects attribute just like all the models we have created so far. Now here we have a method called getForModel. This is a special method that is only available in this manager. Remember, I told you that the objects attribute returns a manager object, which is a gateway to the database. So content type manager has a special method called getForModel. So we call this method and give it our product class. Now we get a content type instance. Now more accurately, this object represents this row in our content type table. So this is how we can find the content type ID for the product model. Now you might be wondering why we're not just using the number 11, because we cannot rely on these numbers. In your database, in your development database, the content type ID for product might be 11, but in your production database, it might be something else. That's why first we have to find the content type ID for the product model. Now that we have this, we can use it to filter tagged items. So we say tagged item.objects.filter. We're going to give it two filters. First is content type, which we set to our content type object. And then we set object ID to the ID of the product whose tags we want to query. Let's say product number 1. This should be calculated dynamically. For example, depending on the product that the user is looking at, we're going to get the product ID from the URL and pass it here. But for now, let's not worry about that part. So this will return a bunch of tagged item objects. Now back to our database, look at our tagged item table. In this table, we have a field called tag ID, which is a foreign key to the tag table. So the actual tag is not stored here, it's stored in this other table. So we need to preload this field, otherwise we'll end up with a lot of extra queries to the database. So back to our code. Here we're going to call select related to preload the tag field. Now let me show you a better way to format this code. It's getting a little bit ugly. So we can put this on a new line. Now we get an error because Python interpreter doesn't know that this line is the continuation of the first line. To solve this problem, we add a backslash here, and now the error is gone. So I would like to indent this line. And then one more time, we put filter on a new line and add a backslash here. And then format our code like this. I think this is nicer, especially when we're building a complex query by chaining a bunch of method calls here. So this returns a query set. Let's get it. And now we can add a new key value pair in our context object. So we can call that result, or we can call it tags, and set it to list of our query set, list of query set. Now let's run our query and see what happens. So refresh. Good, no errors. So we have two queries. The first query is for finding the content type ID for our product model. And the second query is for reading the tags for a given product. Like currently, we don't have any data in these tables, but if you're curious, you can just populate these tables and render the tags on the page. So this is how we can get the tags for a given product. Now in the next lesson, I'm going to show you how to encapsulate this logic inside a custom manager so our code is cleaner and easier to work with. So our tags app is decoupled from the store app, but writing code like this is not ideal. Every time we want to find the tags for a given object, first we have to find the content type, then we have to go to the tagged item model, we have to preload the tag field and apply a filter. There must be a better way. So wouldn't that be nicer if we had a method like tagged item.objects.getTags for product1? Obviously, calling this method is much nicer and cleaner than writing all this code. So let me show you how to implement this method. To do this, we have to build a custom manager for the tagged item model. So we want to replace the default manager that is returned from the objects attribute. We want to replace that with a custom manager. So let's go to this class. Before this class, we have to create a custom manager. So class tagged item manager. This class should inherit from the manager class in the models module. So this class is the base class for all managers. Now here we're going to implement that custom method. So get tags for. Now the first parameter should be self. So this becomes a method of this class. We also need two more parameters, object type and object ID. Now let's go to our playground and grab all this code and move it to our new method. Okay, let's fix the indentation. Good. Now we're going to replace product with object type and one with object ID. As simple as that. Now finally, we're going to return this query set. So we can return it right away. So we're done with this. Now we need to use this manager in the tagged item model. So here's the tagged item class. I'm going to add a new attribute here called objects. We're going to set it to an instance of the tagged item manager class. As simple as that. Now we can go back to our playground and use this new method to get the tags for a given object, like a product. All right, let's talk about the caching mechanism built into query sets. So let's call product.objects.all and store the result in a variable called query set. Now, you know that when we convert this query set to a list, Django is going to evaluate this query set, and that's when it's going to go to the database to get the result. Now, this is an expensive operation because reading data from the disk is always slower than reading it from the memory. So when Django evaluates this query and gets the data from the database, it's going to store it somewhere in memory called the query set cache. So the second time we convert this query set to a list, Django is not going to evaluate this query again. It's not going to go to the database. It's going to read the result from the query set cache. Let me show you. So back to the browser, refresh. Now let's look at our queries. Look, we have a single query for reading the products. So the second time we convert this query set to a list, Django is going to read the result from the query set cache. Now the same thing happens if we access an individual element from this query set. Again, Django is going to read this object from the query set cache. Now, one thing you need to know about caching is that caching happens only if we evaluate the entire query set first. For example, over here, first we're evaluating the entire query set and then accessing an individual element. In contrast, if we accessed an individual element first and then converted our query set to a list, we would end up with 2 queries to the database. Take a look. So save, refresh, and look, here we have 2 queries. With the first query, we are reading the first product in this table. And with the second query, we are reading all products. So keep this in mind. Even though caching is a great optimization technique, if you don't structure your code properly, caching is going to come back and bite you. So this is all about caching. Next, we're going to talk about creating objects. So far, we've been only querying data. Now let's see how we can insert a record in the database. So let's create a collection object and set its title to, let's say, video games. Now, every collection has a featured product, which is optional, so we don't have to set it, but let me show you how to set this field and create a relationship. There are basically 2 ways to set this field. We can set this to a product object, like the product with the ID 1. Here we could also use PK, and with this, we don't have to remember the name of the primary key field, so it can be ID, code, or whatever. Now, the second way to set this field is like this. We can set collection.featured product ID to 1. So we can either use a product object or use the value of the primary key field. Now, either way, this product should exist before we can create this collection. In other words, we cannot create this collection and this product at the same time. This is how relational databases work. The parent record should exist before we can create the child record, right? So assuming that we have a product with this ID, now I'm going to remove the last line and set the featured product to a product object, okay? Now there's another way to initialize this collection. Instead of setting these fields individually here, we can set them using keyword arguments when creating a collection object. So here we can set title to video games. Now there are a couple of problems with this approach. One problem is that if you noticed, here we didn't get IntelliSense. So as I was typing title, look, we are not seeing the name of this field. We're just seeing the name of other classes imported in this module. So that's the first problem. In contrast, when we use the dot operator, look, here we can see the name of the fields in this class, okay? The second problem with using keyword arguments is that these keyword arguments don't get updated if you rename these fields. Let me show you what I mean. So let's go to the collection class and rename the title field to name. Now, back to our playground. See what happened? The title field is updated here, but not over here. So the keyword arguments don't get updated. That's why I personally don't like this approach, even though sometimes it can make your code shorter. So let's set the fields individually here. Now, to insert this collection in our database, all we have to do is call the save method. So every collection has this method for saving data. Now, in this case, because we haven't set the ID of this collection, Django will treat this as an insert operation. So it's going to create this collection, okay? Now, there is another way to write this code. There's a shorthand. So instead of writing these 4 lines, we can call collection.objects.create. And here we have to set the fields using keyword arguments. So we set name to whatever and featured product. Look, again, we don't have IntelliSense. So we can set featured product ID to 1. So the create method is available in the manager object. And what happens inside this method is exactly what we have on the top. So this method is going to create a collection object. It's going to initialize this object based on these keyword arguments. And then it's going to call the save method to insert this collection in the database. And of course, at the end, it's going to return the actual collection object. So either way, here we can read the ID of this new collection. That's going to be available here as well. So the second approach appears shorter, but again, here we have the problem with our keyword arguments. So if you rename these fields, our code is not going to get updated. So I always prefer to use the traditional approach. And before we finish this lesson, let's go back to our collection class and rename this field back to title. Good. So let's make sure everything works up to this point. Save, back to the browser, refresh. Now let's look at our query. So we have an insert into statement for inserting a new collection with these values. All right, let's talk about updating objects. So here we have this collection. Now to update it, all we have to do is set its ID or primary key. So in my database, this new collection that we created, its ID is 11. So I'm going to set PK to 11. And by the way, even though I'm using a keyword argument here, this is not going to be an issue in the future, because if tomorrow we decide to rename the ID field to something else, our code is not going to break. PK will always work. Okay. So here we have an existing collection. Now let's set its title to games and featured product to none. Save, refresh. Good. Let's look at our query. So here we have an update statement for setting the title and featured product ID. Perfect. Now let me show you something tricky. Let's say we only want to update the featured product for this collection. So we don't want to set the title. Save, refresh, and look at our query one more time. Now, something crazy is happening here. Can you tell? Look at this line. Django is setting the title of this collection to an empty string, and this causes data loss. So as part of updating this field, we end up losing the title for this collection. But why does this happen? Here's the reason. This collection object that we have in memory, by default, its title is set to an empty string. So even if we don't explicitly update this field, Django is going to include it in our SQL statement. And this is where Django is different from some of the other ORMs you might have worked with. Some other ORMs out there have this feature called change tracking. So the SQL statement that is generated here will be based on the fields that are updated. So to properly update an object in Django applications, first we have to read it from the database. So we have all the values in memory, then we can update it. So over here, instead of creating a collection object, first we have to get it from the database. So get pk equals 11. Good. Now we have a collection with all the values, so we can update certain fields. Now you might worry that reading this object first may cause a performance penalty. But speaking from experience, I'm telling you, this is not an issue in most cases. So don't try to prematurely optimize your code. Always profile first, see if you really have a performance problem in this part of code before optimizing it, okay? So once again, reading this object first before updating it is not an issue in most cases. But let's say in your application, you really have a performance problem in this part of your application. So let me show you how we can avoid this extra read. In the previous lesson, we talked about a convenience method called create. So collection.objects.create. Now, on this manager, we have a similar method called update for updating objects. And with this method, we can avoid reading this collection first before updating it. So we can update it directly in the database. So we call this method and pass one or more keyword arguments. So here we can set featured product to none. And that means here we have that problem with keyword arguments that I told you about. So with this new method, we can avoid reading an object first, but at the cost of making our code a little bit fragile, okay? Now, this update method will update this field for all objects in our query set. So if we use it like this, it's going to update the featured product for all collections in the collection table. But here we want to target a particular collection. So before calling the update method, first we have to filter to get the collection with the ID 11, and then we can update its featured product. So let me comment out these few lines and run our code one more time. Refresh. Good. So take a look. With this new implementation, our update statement is only setting the featured product. Okay. All right. That's it for this lesson. Next, we're going to talk about deleting objects. All right. Let's talk about deleting objects. Again, we have two options here. We can delete a single object or multiple objects in a query set. So if you have a collection, we can delete that collection by calling collection.delete. Pretty straightforward. Now, to delete multiple objects, first we need to get a query set. For example, we can say collection.objects.filter. Let's say we want to delete all collections whose ID is greater than 5. So here we say ID greater than 5. This returns a query set. Now on that query set, we can call the delete method to delete all these objects in one go. So these are two ways to delete objects in Django. Now it's your turn. Download the PDF below this video and spend a few minutes on the exercises. When you're done, come back, see the next lesson. Sometimes we want to make multiple changes to our database in an atomic way, meaning all changes should be saved together, or if one of the changes fails, then all changes should be rolled back. A typical example is saving an order with its items. So let's create an order object. Here we should set the customer or the customer ID field, and then save the order before we can save its items. This is how relational databases work. We should always create the parent record first before we can create child records. Okay. Now, after this, we can create an order item. Here we should set a few fields. First, we should set the order to the order that we just created. Then we should set the product or product ID. We should also set the quantity and unit price. With all this, now we can save this order item. Now imagine while saving this order item, something crazy happens. We get an exception. What's going to happen? Our database is going to be in an inconsistent state. So we'll have an order without an item. We don't want this to happen. So this is where we use a transaction. So we're going to wrap both these operations inside a transaction, and either both of these will be committed together, or if one of these operations fails, then both changes are going to get rolled back. So on the top, from Django.db package, we're going to import the transaction module. Now in this module, we have a function called atomic, which we can use as a decorator or a context manager. So we can apply it as a decorator to this view function, and this will essentially wrap this entire view function inside a transaction. So all the code that is here will be run inside a transaction. Okay. Now, sometimes you want to have more control over what parts of your view function need to be inside a transaction. In those cases, you can use this as a context manager. So I'm going to remove this decorator from here. Let's say we want to wrap these lines inside a transaction, but let's say we have some other code here that is not going to be part of a transaction. So we're going to leave this out and then wrap the rest of the code inside a with block. So we say with transaction.atomic. This returns a context manager. Now we need to indent this code. Good. Now let's test this. So I'm going to run the code, refresh. Good. So now in our database, let's open a new query console and say, select everything from store underline order and order by ID in descending order. So here's our new order, order 1001. In this case, both the order and its item were saved successfully. But to demonstrate an exception, let's go back to our code and set product ID to -1. So we're going to get an exception here because we don't have a product with this ID. Now, back to the browser, refresh. So here's the integrity error that we just got. Now let's look at our database. So since we have wrapped both these operations inside a transaction, now we should not have a new order because we couldn't save its item. Take a look. So I'm going to rerun this query. See, there is no new order here. So this is how transactions work. All right, we covered a lot about Django ORM. The last thing we're going to cover in this section is executing raw SQL queries. So sometimes implementing certain queries using Django ORM can get overly complex. You might end up with crazy annotations or filters. In those cases, you can always write your own query by hand and execute it directly using Django ORM. Let me show you. So we're going to call product.objects.raw. So every manager has this raw method for executing raw SQL queries. So we call this and give it a query like select everything from store underline product. So Django is going to execute this query. Then it's going to map the column names to fields of product objects and return a bunch of products. Well, more accurately, it's going to return a raw query set. So we're going to get a query set, but this query set is different from the other query sets you have seen so far. So here we don't have the filter method, we don't have annotate, because these methods don't really make sense here, okay? So for this demo, I'm going to add a new key in this context object called result and set it to list of query set. Now, back to the browser, refresh. So here is our query. Great. Now, a few things I need to highlight here. In this case, there is really no point writing this query because Django can perfectly generate this for us. So use this approach only when dealing with complex queries. If you end up with complex annotations and filters and realize writing the same query using raw SQL is easier and cleaner, then go for this approach. Or if the query that Django generates doesn't perform well, then again, this is another case for using this approach, okay? Now, here we can also specify column names. So instead of selecting all columns, we can select ID and title. And Django is going to load only these two fields. So the other fields are going to be deferred, okay? Now, sometimes we want to execute queries that don't map to our model objects. In those cases, we can access the database directly and bypass the model layer. So instead of using the raw method, we're going to use a different approach. First, on the top, from Django.db, we're going to import the connection module. In this module, we have a function, cursor, for creating a cursor object. So we get a cursor. Now this cursor has an execute method, and here we can pass any SQL statements, no limitations. So we can have a select, we can have insert, update, and delete. Now, after executing our query, we should always close the cursor to release the allocated resources. So the proper way to use a cursor is to wrap it inside a try finally block. So inside the finally block, we close the cursor. So this way, if something goes wrong, we don't end up with an open cursor. But you know that try finally blocks are a little bit verbose, so it's much easier to use a cursor using a with statement. So let's delete these lines and say with connection.cursor. This returns a cursor object. So using the as keyword, we give it an identifier like cursor. And now we can use this cursor inside the with block without having to explicitly close it. So the cursor is always going to get closed even if there is an exception, okay? So this is how we can execute raw SQL queries. Now, one last thing before we finish this lesson. We also have another method here for executing stored procedures. So we can call a stored procedure like get customers and give it a bunch of parameters, 1, 2, a whatever. This is much better and cleaner than writing your SQL queries in the middle of your Python code. So you encapsulate your SQL queries inside a stored procedure and then call that in Python. Now, that really goes outside the scope of this course, but I covered it in detail in my SQL course. So we're done with this section. In the next section, we're going to talk about the admin interface.